Bismillahirrahmanirrahim. Assalamu students. I am Sabir Hasnan, your science subject teacher from grade 8. If you remember, in previous video we discussed about energy and just revise a few things from the first chapter: energy, types of energy and its unit, and later on we discussed the law of conservation of energy. After that we discussed about a new concept which is the diagram, and that is called Sankey diagram. And if you remember, in that diagram we discussed about the energy conversions. So a simple way of representing the energy conversion by using arrows. So today our aim is to discuss about power supplies and voltage. So power supplies and voltage. Any or all electric circuits need a source of energy to force the current to flow. For example, if we will consider the example of television, definitely that the electric circuit in that needs current, which actually which that current is actually converted. That current came from the main energy source, and then later on that is converted into sound energy and light energy and heat energy as well, which we discussed in the sankey diagram. But the point is here that television cannot work without electricity, that need a source of energy to convert that electrical energy into light energy or other forms. If we look at the other examples, like the wristwatch, like the wall clock, like remote control of your TV, or the remote control of your AC at your home. So in all these cases, if you look inside that, we use cells, and those cells actually are basically the sources, are basically the power supplies. Okay, without cell, that remote control cannot work. That either that is remote control of AC or television, or the wall clock will not rotate if there would be no cell in that. Similarly, in the wristwatch, so they all need a power supply. Okay, so a power supply is basically an electrical device that supplies electrical power to an electric load. So what is the basic function of the power supply? The basic or the primary function of power supply is to convert electrical current from a source. So let's suppose we have a cell. So that cell actually converts chemical energy to electrical energy, and that electrical energy will be in the form of current, I mean electric current. Okay, so that cell used in the remote control actually converts that chemical energy into electrical energy. So that is in the form of electric load, which is converted from the power supplies. So all electronic objects, either electric iron, electric kettle, television, refrigerator, light bulb, tube light, AC, whatever that would be, they need current, and that current comes from some energy source. Now let's move towards voltage. So a driving force of the current is called voltage. Definitely current will flow into the electric circuits. Current will flow, for example, we would take the example of electric iron. So current from the main switch goes to the electric iron. Similarly, current from the main switch goes to the AC, to the tube light, to the bulb, to the fans, or to the TV. All is from the main switch. So that basically a driving force which moves current from one end of the circuit to the other end. So that driving force which is of a current is called voltage. So the unit of voltage is volts. Keep in mind the unit of voltage is volts, and it is represented by V, capital V, keep in mind. Now the next thing, and which is the basic question, how we measure the voltage, or its another name is a potential difference. So a voltmeter is a device which is used to measure voltage, and voltage can be measured across the components of the circuit. In next slide we will discuss about this sentence, the voltage can be measured across the component of the circuit. Look at the figure on the right side. This is a device which is called voltmeter. Okay, so for this purpose voltmeter is connected in parallel to that component. So whatever the component that would be where we want to determine the voltage, we will connect the voltmeter in parallel. Let's try to understand these two sentences, or the second point as shown in figure. As I told you earlier, voltage can be measured across the component of a circuit. For this purpose voltmeter is connected in parallel to that component. So look at the circuit. We have a battery or a source. In the first figure, here we have a resistance. We will discuss resistance later on. And here we have a load, which is maybe machine, maybe whatever that would be. So if we want to determine the voltage across resistance, look, we will connect that voltmeter in parallel to that resistance. So voltmeter is connected in parallel to that component. So here the component is resistance. So if we want to calculate the voltage across resistance, we will connect voltmeter in parallel. Look at the next figure, second figure, which is DC supply. Again, question is this: what is DC supply? We will discuss it later. And this time our aim is to find out the voltage across the bulb. So when we want to determine the voltage across the bulb, we will connect the voltmeter. This is symbolic representation of voltmeter. So we will connect the voltmeter in parallel to that bulb. By this way we can determine the voltage of, or the potential difference across the voltmeter. I hope there is no confusion how we can connect the voltmeter in parallel with that component. Either that is resistor, either that is a light bulb. Now the next and important factor to determine the correct voltage, this is very important thing. Voltmeter must be connected the right way round. If not, the pointer moves in the wrong way and meter may be damaged. So whenever you want to connect, whenever you want to determine the correct value of the voltage, so keep these two things in your mind. Look, we have two different wires. Okay, one is the red one, another one is the blue one. You can replace the blue one with the black one. As I told you in the class as well, you can replace the blue one with the black one. So in this case, always connect the positive terminal of the battery or the positive end of the circuit to the red one wire. Okay, and the black one or the blue one is connected to the negative terminal. then we can get the correct value. If we do not connect the positive and I mean the red wire with the positive and the black or blue with the negative, we do not get the correct answer or the correct voltage on the voltmeter. So here is the correct voltage, and in this case we used a battery. So look, battery has a positive terminal and the negative terminal. If we another example, if we want to determine the voltage of a cell which is 1.5 meter cell, 1.5 volt cell. So if you look at the cell, they are two symbols on that. One end is positive, another is negative. So the positive end of that cell is connected to the red one, and the negative end or the black or blue is connected to the negative. Why? So by this way we will get a 1.5 volt on the screen of voltmeter, okay, in case of cell. I hope you learned a lot from this video. In next video lecture we will discuss about resistance and how we can control the flow of current. Thank you very much. Take good care of yourself.